thank you all very much for joining in here to aspConf. I'm very excited to be presenting. What we will be covering today in my session is a smooth transition to HTML5 using MVVM development patterns. So a little bit about myself. My name is Chris Bannon. If you'd like to follow me on Twitter, ask me any questions, you can do it there. B4NN0N is my handle. You can also feel free to email me any questions, comments, thoughts on life, whatever you want. I'd love to hear from you, so please feel free to contact me. So I'm a product manager for a product called Wijmo, and I work for Component One, one of the sponsors here today. We're definitely proud to be sponsoring this conference. We joined it last year as MVCConf. You know, we're really excited about it. Great sessions, great group of people running it. So glad to sponsor, glad to be a part of it. So a little bit about the product I manage, Wijmo. It's a kit of 40 widgets. It's built on jQuery UI. We use a lot of HTML5. It's themed with ThemeRoller, and we do support MVVM. So today's session, what we're going to cover here is really a practical way of migrating to HTML5 application development, specifically coming from Microsoft web background. So Silverlight, web forms, so things that really help and translate over into HTML5 development. And when I say HTML5 development, I'm really speaking just HTML markup and JavaScript and with some styling in CSS. So really nothing mind-blowing there, not really even pushing the envelope of what HTML5 is capable of, just general development, client-side development. So I am going to do a bit of talking today, so be warned. There's going to be some hot air here, but I think it's important. We have sat down and taken three, actually more than that, but we'll talk about three today, three Silverlight rich internet applications, and ported them to HTML5 using this approach, and this, there's nothing out of the ordinary that we did. I just want to let everybody know about how we did it, give some general guidelines, talk about the tools that are available, and of course hit on the pitfalls, things that we've run into issues with, and things to look out for, and of course we'll show some code as well. All right. So before I do start talking my head off, I would like to just show you guys what we've built and some of these real-world applications that we sat down and tried to port, because we really had people asking us pretty much on a daily basis how easy it is to go from Silverlight to HTML5, or what's the process like. So we really just had to sit down and do a couple of these applications in order to be able to answer those questions for people. All right, so I'm going to just show a quick couple applications here, hit their functionality, and feel free to jump in, ask any questions, and I'll try to cover those throughout the session or at the end. We'll definitely have time for questions at the end. So this is a dashboard that kind of is a mashup between a mapping application and demographic data. So what you're looking at is a Silverlight application here. And as I pan around the map and change the basically where this crosshair is pointing, the data below updates. So it's context sensitive. All these visualizations down here based on the area of interest. So you can see there's different median age, the different breakdown of male versus female in different location, median household income, net worth, things like that, and you get an idea for different locations and their demographic. So it's a very interactive application, and this was a really nice demonstration of something you can do in Silverlight to get all this interaction animation quite easily. So let me hop over here and refresh the page to show the HTML5 version we built. And this application was the first one we built as a port from Silverlight to HTML5. So I would say it took the longest, and that was, just kind of learning some lessons along the way, and more of ramping up on how to do the port versus the actual technology itself. So you can see it's almost pixel perfect between the two. It's not quite pixel perfect, but I can move around the page. Everything below here, all the demographic data is going to update just as it would in the Silverlight version. What's happening here is as I change the location, there's a web service call that's getting data. I'm populating a view model with that data, or updating a view model rather. And everything below in these little tiles is animating to the new values, basically, if the animation might not be translating very well here. So, all right. So that's the geographic dashboard that we have. We'll do one more just to give the effect. Okay. Now another application we have is a little kind of a stock portfolio. It's just an application where you can add some stocks that you want to monitor, and it gives history data in this line chart below. So I can turn stocks on and off in the chart. I can add stocks, remove stocks, things like that. This one is a pretty basic example, but we also wanted to be able to port this one, so we ported this one. This one looks very different, but it's the same concept in both Silverlight and HTML5. So I have stocks that I'm watching. Below I have a chart with all the different stocks plotted on it. I can turn them off. I'll let this go for a second here to kind of make sure you can see the chart update visually. Alright, so now I only have 3 stocks because I've unchecked everything but 3. I can change the time span, which is going to redraw the charts. And this is all the same functionality that the Silverlight one had. Last but not least, we have a sales dashboard that we developed. So this is just HTML5 version. I'm just going to show you some of the features that it has. And basically it's year over year sales data, and then you can click these buttons to segment it by quarter. And if you click the buttons, let's click Q1 here, everything below is going to update to reflect the change in data. So it's just doing a web service call and filtering the data on the server, sending it back down to the client, where the client's reacting to the change in data. Again, I don't know how well this animation is translating, so I'm trying to give it some time here. You can probably at least see this big number here change. We'll just do one more change and then we'll move on. Alright, so that's basically these applications that we've sat down and kind of, this has been our litmus test for taking something that could really only easily be achieved in Silverlight a couple years ago, to today, where we can now do this in HTML, JavaScript, and CSS. Okay, so now that you got to see some shiny things, I am going to talk a bit, and then we'll get back into some code shortly. So let's talk about, why you would want to even do something like this, and then how you go about doing it. So why do you want to use HTML5? Virtually every computing device supports HTML and JavaScript. I can't even stress that enough. JavaScript is the programming language in HTML5, and it runs everywhere. It runs on your phones, it runs on tablets, it runs on desktops. There's people that build weather applications that run on refrigerators using JavaScript, so it pretty much can execute on any device. So it's the lowest common denominator if you want to take an application and deploy it in many different devices, including full computers, servers, and even devices and beyond now. So the benefits of using HTML5, really, number one is mobile. So another question or comment we get here on a daily basis is, hey, my boss, the CEO or similar, got an iPad and he can't use our application from an iPad, right? So everybody is in this dilemma. Their boss wants to use their application from his iPad, and he or she can't. And now all this time and effort you've invested in something like Silverlight, Flash, or other is, it's completely useless on a device like that. So HTML5 is a very easy way of taking your existing skills and kind of building a different type of web application that will work on iPhones, iPads, Android, Windows Phone, all of the above. So that's really probably the biggest benefit, or at least the biggest driving factor when making these decisions. Performance is another one. So traditionally when you're doing server-side development, you've got thousands of sessions all connecting to one server. And yes, servers are powerful, and you might have a server farm and whatnot, but there's so much of that computing that can be now done on the client at just a good a performance, and you're taking out the bandwidth and the HTTP connections and all of that. So much of the programming now can be pushed out to the client. You can have a lot of this logic and operation done on the client side and just basically send data down from the server. So obviously there's a wall you can hit there, and you can't just say, oh, everything's going to the client. For security reasons, for performance reasons there, you don't want to send your whole set of 300 million records down to the client, but you get the point. You can now send applications to a client that are performing almost at compiled native speeds, and JavaScript's executing so fast that you really don't have to worry about basically performance on the client. And then another big benefit is you can share a lot of your code in multiple platforms. So I don't really think there's a write once, run anywhere, but when you use the patterns that we're going to cover today, you can share a lot of code between, you build a desktop web application. You can share a lot of code to build a mobile web application. You can even bundle that up in a PhoneGap project to build native mobile applications to deploy to devices. And now with Windows 8 Metro coming out, you can even build native desktop applications using JavaScript. So you can share a lot of code. I don't think you ever really make one application that goes everywhere, but in a sense you can reuse, 90% of your code base if it's done right. So some of the principles that we use when migrating to HTML5, port your programming knowledge. You don't have to throw away any of that when you're moving to HTML5. Port your patterns and practices. So, you know, if you have guidelines in place, there's definitely benefits to using those. If you don't, look out for style guides, and you know, get everybody using them. And there's certainly knowledge, patterns, and practices, and code conventions that easily translate into JavaScript and HTML. And probably most importantly is you really want to focus on porting your business logic and not your code. You want to, you know, look at your application's functionality and what it does as a function, and not really go line by line through your application and try to find the equivalent, you know, in JavaScript that there is in C#. That's not your best bet, but you can, you know, look at the big picture, port business logic, and the code will just kind of, I think, follow. All right, so that was you know, why and the principles we use. So how do you go about doing this migration? So fundamentally, and this is our experience, and there's certainly other ways of doing it, but from our experience, this has been a really smooth transition. Use a familiar development pattern, and we recommend MVVM. So we'll dive into what MVVM is, but basically it's used by a lot of Silverlight developers already. So you're going to reuse a lot of your knowledge there. We also recommend using Knockout for MVVM. So it's pretty much the standard for MVVM development in JavaScript. Thousands of developers are using it. It's well tested. It's really solid, and it's very easy and very familiar to start using. And then use some kind of UI controls with MVVM support for quicker development. So one of the things that can slow you down most is having to worry about cross-browser consistencies, and making control or rich user interface with just HTML, CSS, and JavaScript. So things like jQuery UI really are beneficial when building these applications, because they will basically support IE6 and above, and all of those browser inconsistencies that can suck up so much of your time. So definitely look at the MVVM pattern when doing these ports. So what is MVVM? MVVM stands for Model View View Model. So model is the data for your application. An example is a web service. In most cases today, it is a web service, and you probably already have a web service if you're doing Silverlight development, and that is what's providing data to your application. The view model is a pure code representation of the UI model. So think of this as it doesn't have to necessarily match your data model exactly. It's similar in that it's going to provide the view with information that basically is shaped from the model, but it also can have things that the view needs. So it can have things in it that particularly are related to the user interface. But it's pure code. So an example of that is you have a JavaScript class like that you can create, or object. So the object representation of your UI in JavaScript. So it's all code, no HTML or any of that. And then you have the view. The view is the visible and interactive user interface. So this is where the HTML, CSS, and JavaScript UI, something like jQuery UI widgets, comes in. This is the tangible interface that you can see and feel and touch. So the view model is kind of like the middleman between model and view. And again, this is a pattern that really emerged in Silverlight and WPF development, and I think it really translates well into HTML. because it fills gaps that are there when working with JavaScript. So it's really worked well for us. So let's look at some code here. This is an example view model using Knockout specifically. So what we're doing is creating a myViewModel object. And the object has two properties. So this is kind of like a person object, if you will. There's a person name property and a person age property. Now optionally what you can do with Knockout is create observable values. So this property, anytime it changes its value, so person name of ko.observable, and then in there is a string. So his name's Bob. But what that means is that anytime that string changes, the view model is going to notify any listeners of changes. So that really is where you can get two-way binding, and that's really the beauty of Knockout, is this observability. And that's not something that's native to JavaScript at all. So observability is really, really nice to have when doing JavaScript development, and it makes things like data binding possible. And then below the span tag, it's an HTML tag, and you'll notice there's a data bind attribute. The data bind attribute is the key to binding HTML elements to your view model. So this is something that's specific to Knockout. It's a valid HTML attribute, but it won't do anything if you don't have Knockout in the page. So Knockout basically reads this data bind attribute and realizes that you want to set the text property, if you will, of the span tag and bind it to the person name property of your view model. So basically when it renders, you're going to see Bob in a span tag. And if I would change the person name to Joe, you would see that reflected in the UI immediately. So let's go look at some actual code examples. Let's run them in the browser and really test things out here. All right, so I have something, and this is a sample right from Knockout's website. Knockoutjs.com is the website. Definitely go there and check it out. It's a really great site with great tutorials, and this came from one of them. So let's walk through the code here. I have a view model constructor. So this is kind of like a class constructor in JavaScript. It's a way of defining a way of initializing an object and passing in property values during initialization. So view model is the name of the class, if you will. And then inside it, I have these different properties. So the first two are pretty straightforward. I have a first name and a last name, and I'm going to set those to whatever is passed in during initialization. Then if I go down below here to this ko.applyBindings, in the ko.applyBindings, you pass in your view model. So I'm initializing a new instance of view model here, and I'm passing in first name and last name. If I scroll down to my view, I have two input elements. So these are text boxes. And I'm binding their value to properties of the view model. So first name, last name. Now I'm going to run this before really getting any further ahead, and then we'll look at what that third property was. So you can see in the page the two text boxes are filled with the two values. So now if I look back, notice there's no value here. So traditionally there would be value equals Steve, right? I don't need that now because it's data bound. So when this page renders and the bindings are applied, it's taking these values from my view model and actually rendering them in the page, okay? So I can, inspect this, and I can see that it has a value of Steve in there. Oh, it's not showing here in Chrome DevTools. But basically, if you would get the value of this text box, it's going to be Steve. As you can see, it's rendered right in the page. Now, there's also a label below that, so let's kind of look at that and how that's working. So if we look down in this heading tag, I have a span tag that is bound to full name. So full name is a little utility in Knockout that allows you to do computed values. So this is really handy for doing custom formatting and stuff like that in a view model. So full name is not really being set by any specific value, but it's a dependent observable. So it's called ko.computed, and it's a function that basically returns a custom property. So this is just returning a string here. And I'm taking the first name and last name, and these little parentheses actually evaluate it and return the string. Otherwise, if I didn't have those, I would just have the observable itself. So this is if you want to actually evaluate the property and get its underlying value, this is how you do it. So I'm basically combining first name space last name. And anytime first name would change, this computed would get reevaluated and updated. So if we go over to the browser, Jim Sanderson. So I changed the first name, and the label immediately changed. Now there's no code that I wrote that's doing that. Okay. John Smith. Okay. So that is this. That's the power of these computed observables. Let me save this page. And that's also the power of observability. So simply by making it observable, anytime you bind to it, it's going to automatically update as the data changes. So really, really, really powerful. And there's no other really way like this to get binding in JavaScript. So it's really, really powerful stuff. Now I'm going to look at how you would take something and add more of a UI component on top of it. So what I did here is I added Knockout. I also have jQuery UI in the page, and I have Widgmo, which is the library we have on top of jQuery UI. I have a view model. My view model has a val, which is basically a value, a minimum, and a maximum. So this is a very basic view model, probably not very realistic in that this would be it, but this will get the point across and now what you can do. So again, I have an input, right? Just a standard input where I'm setting the val equal to val, or value equal to the val property of my view model. Then what I'm adding here is a div tag, because I want a little bit of a richer component in here to bind to my view model. So this is really cool. Widge slider is just like a jQuery UI slider that we have. And I'm setting its value to the val, its minimum value to min, and its maximum value to the max. So again, these are all bound to the view model. And the slider, the interesting thing is it's doing updates. So it's going to listen to updates on the value, and it's also going to make updates on the value. And below that we have a linear gauge. So this gauge, again, it's got the same bindings. It's got a value that's bound to the val, min to the min, max to the max. And again, if we look at the view model, you can see all of those are in the view model. Let's take a look at that page rendered. All right, so when we initialized it, we set the value to be 50. So if I change that to 80, you'll notice that the slider here updated, as well as the linear gauge. Make sure we have enough time for everybody to see that change. All right. So that's really nice. So UI components can be created, and now you can do this with any type of widget. What you create is a custom binding, and that's exactly what we did. So you notice this is like the widget name here. This could be anything. We wrote these custom bindings so that you could use our widgets with Knockout. We also wrote them for all of the jQuery UI widgets. So you can put things like jQuery UI, slider, buttons, things like that in the page, and initialize them like this. So this is initializing a widget, and it's binding one of its options to a property of the view model. And again, two-way binding. So now I'm actually going to drag the slider, and you can see as I drag the slider, the text box is changing and the gauge is changing. I hope you guys can see that change. All right. So pretty powerful stuff if you're binding. And now imagine you put you could do on a change event, you could post to the server or a save button. But basically your whole view model, it's populated with the most current data. So all you have to do is push your view model to the server, and that's it. So all the change tracking, everything's done here on the client, which is really nice. Now let's take a look at collections. Okay, so what I have here is another view model setup. Now this view model is a little bit different. The only option or property that it has is a collection. So list that's it. And you'll notice instead of observable, I have ko.observableArray. All right, so observable array is a little bit different in that it listens to changes on collections. So add, removes, reordering, things like that. It only listens to collection change events. So it's really important to know this. If you change a property of one of its like nested objects, it's not going to trigger a change. So know that if you're using observable arrays, that's only for monitoring collection changes. So if you want really truly observable objects inside of an observable array, you can do something like this where you have the constructor here of a person, and each person has a ID, company, name, and their total sales. So, and if you'll notice, each of those is bound as an observable. So what we have here is a bunch of observable properties on an object, and we're initializing a new person for each item in the array. So we have 4 people in here, and we're basically passing in Northwind data to them. It's very just basic sales information, and I'm passing these values in, and they're automatically observable because of this constructor. So it's a little much to wrap your head around, but it really makes sense, because when you want to listen to collection changes, you need that observable array, and it's very, very useful. All right. Now, if we go down the page, the real basics of working with collections is that you can do iterations over them in the markup. So this is really nice. You can write for loops. So this is a for each. So before we had things like text or value, but here we have a for each, and what that means is it's going to iterate over a collection. So the collection is list, and if I scroll up, list, remember, is an observable array. So what's it going to do? Anything inside that for each loop is going to get repeated. This is kind of like a template when you're doing data binding, or similar to like a list view. So anything inside here gets repeated for every item in list, and it's going to render out, so it's a table row if you don't know, and then TD is a table cell. So you have 4 table cells. Each of them have their text is going to be bound to the property of the person that they're bound to. So that's the basic usage. So if I would run that, let me comment this out and run that. Okay, so here's my HTML table. You can see I've got 4 rows for each of the people in my array, and 4 columns for each of the properties of the person object we have. So that's pretty basic, but it's very powerful. If I would change that collection, if I added a person, it would automatically draw in this table. Okay? Now let's go back and look at adding some more powerful components in there with that, using that same observable array. So the first thing I have is a div tag, and its data bind attribute is a bar chart. I'm passing the data source option as list. So again, I'm using that observable array, and then I'm just formatting the series list and binding things to like name and sales for my X and Y. Then below that, I have a grid. So it's a HTML table, and the data bind is grid. The data I'm passing in is my observable array list. And then I just have things like allow editing. I'm setting my column specification. And I want the last data type to be a number, so I get a numeric editor. And this is using the Wijmo grid here. But again, you could really write any custom binding handlers here, which is really the power of Knockout. Let me save this. Refresh. All right, so now I have a chart that's bound to the observable array, and I have a grid that's bound to the observable array. And below that, we still have our plain table. So you see the table matches the grid. They're similar. Now here's a really cool part. I can update the data in the grid. And you'll notice that the chart redraws. And this, again, is the two-way binding that really allows you to have these interactive UIs without writing all the code to handle these change events. We used to do this. This application used to take quite a few lines of code to pull off. So it really cuts down on lines of code, in that really the only code we wrote was our view model, right? And that's the beauty of this stuff. I'm not writing change event handlers. I'm not pushing change events to the widgets and the HTML. I don't have to redraw any of this stuff when data changes. And that's, when you look at platforms and features, data binding is probably one of the most powerful features for any platform when you want to do rapid development and really full application development. You need data binding. And this Knockout.js brings data binding to HTML and JavaScript development. Yeah, I mean, that Kendo UI, I believe, has their own MVVM library built in. So it's really up to the developer on what you want to use. So personally, we use Knockout. We try to just, if there's something that's a standard out there that we see like huge adoption on, we tend to just go with that. because that's what most people are going to be able to relate to, and that the knowledge of something like that's going to span, you know, more than just something specific to like widgets. But yeah, certainly you could do something similar with Kendo UIs. And again, I think that they've recognized that this pattern really fundamentally is a good one to build applications in JavaScript with. So bottom line is you should be doing MVVM development. We recommend Knockout, but yes, there's others out there that certainly you could use. Yes, you can. I mean that you can't bind that like just in JavaScript per se. You have to do some work on the server, but I think I believe Brad Wilson just did a NDC talk called Web Stack of Love, and he did just that. He built something like this where it's a view model, and he showed change tracking in JavaScript. So as you change data on the client, it's actually updating the UI. And then he used, I think, Signalar or some other WebSocket library. I think it was Signalar. And then tied it so that the server was updating the client anytime a change happened on the server. So you could absolutely do that. And you could do that by polling, or you could do that by some kind of socketed connection to the server, like Signalar or XSockets, things like that. We actually have another application that we wrote using, or we didn't write, one of our good friends in Sweden wrote, that does that using XSockets, a library, and it's similar. It has WebSockets, and it falls back to, I think, Flash and Silverlight if you don't have WebSockets in your browser. And it does raise events on the client when they happen from the server. So you could do that to push data into the client. And this was a server monitoring application. So they had like how many processes were running, and there was live updating from the server. So you could literally see like a live view of your server health, and as things change, you would get the change on the client. And again, it's just all the less event handling you need to write when you do this type of binding. Something like that would require so many lines of code with event handling to be able to do that kind of live update. So this stuff, just data binding, is so fundamental in any application architecture, and I can't recommend enough that you use it. All right, I'm going to hop back into slides just to make sure we finish up here, and then we'll hit more questions at the end. So that was the examples. Now I'd like to get back into talking a little, more about how we went through that process of porting. I showed you some examples of MVVM. So porting the model, and we'll kind of talk about porting each piece. Porting the model is the easiest part. Almost every rich application out there is using web services. So most JavaScript applications can use the same services that the Silverlight client's using. I mean, unless there's some kind of cross-domain issue you're having, but if you're deploying on the same domain, you can a lot of the time use that same service. And there's also ways of getting around cross-domain with like JSON-P, stuff like that. So porting the model is usually, at least in our experience, the least painful thing. If you already have services, you can use those. Porting the view model. So porting the view model is really what is going to save you the pain when doing these ports. So, and this is where MVVM, this is its strength. So what you want to do is you create JavaScript objects or classes, depending on how you want to do it. Like if you want to do object-oriented stuff and you want to have class constructors like I showed you, you can do that. And you're building their equivalents to what you would have in C# or VB. And when I say equivalents, I don't mean like you use some kind of C# to JavaScript converter. You can if you want, but it's really not that hard to do it by hand. You're looking at your objects in C#. You know what properties they have, what the types are. You know what events your objects raise, methods on your objects, stuff like that. And you do those same things in JavaScript. Sometimes you can use code converters just as a starting point, but honestly, your best bet is to just look at the object model itself and recreate that in JavaScript. Then you want to hook up observability using Knockout. So just kind of a pointer here, you can get yourself into a hole if you just go through and make everything observable. You don't need that. So just look at what your view is going to really need to be observable. Like if you're talking about something that's like an application-wide setting or something like that that's really never going to change, it doesn't really need to be observable. Okay. Only things that are changing on the client or that the client needs to be aware of changes, you need to be observable. Okay, so use it wisely, but I mean don't be afraid to use it. Certainly, and then remember to focus on porting the business logic, not code. Again, just replicate the objects and classes that you have in C# or VB, just replicate those in JavaScript using JavaScript techniques and some kind of style guide or something like that, so that it's going to compile. Also, I don't have it in the slides, but JSLint is a great tool if you want to do sanity checking on your JavaScript. So if you do create these objects and classes, it's going to tell you what you did wrong if there's errors, and you can check out JSLint from Douglas Crockford. He's one of the greatest JavaScript developers probably in the world, and he wrote this so that you can write JavaScript the way he thinks it should be written, and 90% of the world agrees with him. So that's a great way of just doing sanity checks and testing against the JavaScript that you write. All right, porting the view. Basically what you want to do is create HTML that represents your user interface. Very similar to what you have in XAML. Honestly, the HTML is probably not going to be as complicated or have as many elements in it that your XAML does, but it's similar, right? So if you're creating some kind of panel in XAML, you're going to create like a div tag in HTML, things like that. If you have like some kind of labels, they're probably going to be heading tags or something like that. So you want to just make a semantic representation of your UI in the view. So there's lots of help online for that, and it's pretty straightforward on what you need to do there. Then you add the data bind attributes to bind the markup in the view model. And this is something that you can actually go into your XAML if you're doing like a direct port. You can go into the XAML and look at your data bind attributes there. I mean, don't copy and paste, but you can see what properties are being data bound, and then you can see what properties of your view model are being bound to. And that gives you a very clear indication of what HTML elements need the data bind attribute and what to bind it to. And then you want to data bind attributes to turn them into UI controls. Like I showed you with the Widmo stuff and with jQuery UI, you can use those custom binding handlers, and you kill two birds with one stone. You're initializing a UI widget, so you don't have to worry about any of the complexities of building widgets, and you're data binding them to your view model at the same time. So that's going to save you a ton of time. And in Silverlight you're using controls, right? So you want to use controls here the same way. And unfortunately, there's not controls in the box with HTML other than the basic elements. But there's nothing like really rich controls that support data binding. So I highly recommend that you use some kind of widgets. All right, so what are the benefits of MVVM? Some of the benefits are you can have a shorter development cycle. So MVVM very clearly separates between your data, your code, and your UI. So it's one of the harshest delineations in any of the platforms. I mean, it's very clear. So each layer can be developed in parallel and individually, and it also minimizes the turnaround time for your application when you can all work simultaneously like that. You also have improved reliability and easier maintenance. So one of the biggest benefits of view models are that they're testable. So remember, the view model is the pure code representation of your UI, but there is no UI, it's just code. So the beauty of that is that you can write unit tests against it, and there's things like QUnit, and you can actually write JavaScript unit testing, with pass-fail and stuff like that. So you're unit testing your view model so that you know if your logic is sound or where there's bugs, where there's breaks, and if your view model is going to fail before you even try hooking it up to a view. So those unit tests become an asset to your project, and of course maintenance is much easier with those automated tests. So you add a new feature, you run your tests on the view model, everything passes. I mean, that doesn't necessarily guarantee things, but at least you know you haven't broken anything new. So really it's a nice way of being able to QA JavaScript development, is that the view models are completely testable. And that's the same thing with Silverlight, and that's why this pattern just makes sense. So our steps in development. We design the view. So the designer basically creates a plain HTML file. They have some JavaScript. If they want to write their own little hover or interactions, they can do that. But most of the time it's just HTML and CSS. And a lot of the time they'll just hard code stuff. So before you saw where we did data binding for like first name, last name, they would just put like the values actually in the HTML. So they can continue to work and build the actual end result before the view model is even ready. Then we design the view model, and so this is happening simultaneously, keep in mind. We design the view model to support the view, so making sure the view model has all the right properties on it that the view is going to need for data binding. We implement the view model. We implement the view as it's bound to the view model. So we go through and replace all of those like hard-coded values with actual data bindings. And then again, if like the model's not ready, if the web service isn't ready, we'll write JavaScript arrays like I showed you. We'll just put the data right in the web page just to simulate what's coming down from a web service so we can continue development. And that really saves a lot of time. And we can predict more easily how much time each step's going to take when we're kind of working separately on these things and aren't dependent on each other for them. So you also have really improved quality in that you have a lot less overlap between developers and designers. So when you're not doing this type of approach, you have developers writing a lot more code that has to do with UI. So they're initializing things as widgets, and they're writing all these event handlers and updating the DOM elements and listening to changes in DOM elements. And then you have designers that might be doing the same thing. You know, they created their markup, but it's not initialized as a widget yet, or they created their markup and it's not getting the right value. So they either have to go in and write a little bit of jQuery to update the DOM element or ask a developer. And there's this overlap and there's this big gray area between what the developer does and what the designer does. So this makes it very easy for designers and developers to stick to what they know and really specialize and write high quality applications on. The developers are just writing the business logic and the designers are just writing their UI. It's really nice. and then they can both work at the same time, so you're delivering a higher quality work faster. Flexibility is another huge benefit. So when you have this loose coupling between views and view models, you can use multiple views for a single view model. So this is really what's one of my favorite features here, is that for that sales dashboard, we actually have it running on we built a mobile view, we built a desktop view, and then we even built like a Windows 8 Metro view. So we used that same view model one time, or we used that same view model 3 times, literally the same view model, because there's no code that we needed to change in the view model, because it was just basically the business logic for the client. And then we built these customized views that just basically bound to the same view model. So the view is super lightweight. It's just basically the UI, and all these different views can share a single view model, which is very powerful if you're talking about that, write once and share a lot of code between different platforms. Standardization. So using the same binding mechanisms in multiple applications, developers start to really ramp up. So our first application took a little while to learn. Once we got that, we flew through the other applications quickly. And then you have all these assets that you can reuse, like your unit tests. You have markup and styles that you can reuse. UI controls, if you develop them or use them, can be reused. You can take common forms that you build and reuse those. So when you have this standardization like this, it's very easy to treat all of these pieces as assets and move them into different applications. So challenges when porting to HTML5. I feel like I'm talking a little bit, so I'm actually going to jump over to code for a minute here. I'm not going to talk about challenges just yet, so feel free to jump in if there are any questions right now. So you're talking about like bubbling up changes. Yeah, I believe it. Does the parent view model need to be observable? If you want to bind to it, at that level, yes. Otherwise, you just bind to the child. But I believe, I don't know exactly. I'd have to try it out. But I believe it's going to bubble up to the parent. Possibly even no. Yeah, and I believe it's controllable too. Like if you don't want everything bubbling all the way up, I believe you can control that. But yeah, I would have to look further into that. I'm not quite a knockout expert. I'm just a big fan. Okay, yeah. So this is how we did it. What we did is we literally like took this application that I have open right now. It's just that sales dashboard, which let me give you the reference here just so we are all on the same page. This application is in Visual Studio. This is what it looks like. It's just a couple scripts. It's an index page, and really the magic is in ViewModel.js. So really these two things are really what's driving it. So yeah, we basically took the HTML markup from index. We brought it into a Windows 8 application. We took our view model, brought it into a Windows 8 application as is. We didn't change anything. And yes, Knockout itself we brought in. So we didn't use WinJS at all. We literally just took this application and used things like the Metro style and CSS, and then I changed the layout. I used like Flexbox for the layout instead of this custom layout that we wrote. So literally I didn't change any of the JavaScript at all. And that's I think a choice. I think some people are going to just do different applications using WinJS APIs, but if you really want to just reuse all your JavaScript and not write device-specific JavaScript, you could do something like this. There might be people at Microsoft cringing as I say that, but I don't know. I think that's the beauty of the Metro.js framework, is that it is wide open, and I think people can do things like that. So we did it, and we have it working, and it couldn't have been easier. So we didn't use WinJS, but I imagine you could have converted it to use the observability API in there instead, but we just didn't. All right, so I'm going to actually talk through the sales dashboard a little since the subject came up. This one is a complete application, so there's quite a bit of code here. I'm just going to run through quickly just to give you an idea of what it really does. So we have our view model. I have a date range, which really just signifies what quarter we're in, if you want to do a single quarter at a time. Date values. I have a start date and end date, which is computed. So actually, I'm listening to changes in date values and changing start date and end date based on those as computed. Then all the data, and this data is what my tile, all those little tiles are bound to. It's just a bunch of observable arrays. And these observable arrays get populated in my load functions. So I have like load totals, where I'm just calling a WCF web service. I'm then looping through the data, and I'm pushing data from the service into the totals array. So this is my observable array, totals, and I'm pushing new items into it. Now, data item, again, this is similar to what I did with that person object, so it's a constructor. Let's go to where that is. It's probably below here. Data item, so data item, just name value pair, and then I'm making those observable. So again, as they change, they're notifying the view model of change events. So all those load functions are just loading, calling different services that load different types of data, like by region, by partner, by type, all of that thing. So then if I go into my page, which is my view, I have the tiles. So here's one of the tiles. Let's see here. And I have things like a radial gauge, and that's bound to the total. You saw where we were filling the total. Then I have a span tag where I'm actually setting the text, and I'm using globalize. So this is actually formatting values and localizing them. So I could localize it to, I think the original version we did had euros in there instead of dollars. So this is where you can actually do formatting in the view, which is also arguable whether that should be done in view model or view, but here we did in the view. And I'm formatting it as currency, and then actually adding an M on there for million since it's representing million. Below that I have a for loop where I'm actually looping through each totals by type. And then I'm creating a just a little panel here that has some different UI. So it's got a heading tag with the name of the type, and then it's got a gauge with the value of the type. So before I go any further, let's look at those specific elements and what we created. So here's the one big gauge, the blue gauge. And it's bound to the total. This text here is the one that we did the globalize localization on. So you can see that it's got the $sign. The data itself was just 70. It was a number that came from the server, and I was able to basically parse it and turn it into this $sign 70 million. So below that, all these 5 gauges were actually in the for loop. So these are all coming from an array. So each gauge was initialized in one of those template items in my for loop, and it had like the same thing, the heading tag with the dollar value, and then the value is the needle in the gauge. And then we did the same thing for this bubble chart, bar chart, pie chart. And let me just jump back into the HTML. I won't describe everything here, but you get the picture, right? So my bubble chart, bar chart, pie chart. Very, very simple. So this is for the whole application. And a lot of this is just for layout. A lot of the markup here is just for layout. The widgets themselves and the actual data bound stuff is pretty straightforward. So, and then I just have some helpers for resizing. This is actually a responsive application, so let's see if it'll work here. It might not. But if you go down to like a mobile form factor and refresh it, I haven't tried this on like a desktop browser, but this is one of the ones where we have some mobile specific views. Yeah, it looks like it's not going to work. Yeah, I think we have stuff in there that's just if it's on a device. So, yeah, so that's the gist of building like an application like this. And again, we have these. This is similar. It's a for loop that creates tiles for each element or for each object in the in like the median age. It creates this chart. Gauges, similar, very similar stuff, bar chart. So I'm not going to go through all that. I just wanted to kind of jump over and show you what one of those applications looks like under the hood. And when you look at it in Visual Studio, it's really very straightforward. Index page and view model.js, that's pretty much all you need. I mean, the other stuff is the bells and whistles, but that's really the minimal you need. All right. Okay, so now let's talk quickly about challenges. Challenges that we came across were development tools. So really, JavaScript's development tools are not as mature as Silverlight's. That's the bottom line. I know there's good text editors out there. Visual Studio is getting a lot better, but it's just not the same. If you're used to compile time error detection, code refactoring, and IntelliSense, some of that's there, but it's just not the same. UI controls, like I said, Silverlight, it's got a control concept. So does ASP.NET. You have this fundamental control. You can inherit from control. You get all the benefits of it. There is nothing like that in HTML. So definitely, that's why we recommend looking at like jQuery UI, looking at Widgmo, trying to find some kind of UI widgets that will help you in building applications where you don't have that in HTML. And that's one of the things that really can suck up a lot of time. Data access. So Silverlight provides really rich and mature set of business data tools. So you can get data in JavaScript. It's just more of a manual process of writing AJAX requests and consuming the data. You don't have this rich set of features on native collections like arrays. Like you don't have grouping, sorting, filtering, things like that on your native collections. So that's stuff. Again, there's tools for it, but it's not out of the box. All right, so that's the presentation. I'd be happy to take questions now if there are any more before we wrap up, and I'll just leave the resources slide up here while we do that.